Hello YouTube, thought I'd do a quick video here. I've been asked through email if I'm going to sell a circuit board interface, and the board that we're talking about is the interface board for the Retevis RT97S or the Midland mxr10 GMRS 2A radio repeaters. Those repeaters have a data port on the side of them. So if you want to hook up those repeaters to a computer so that you can have like time announcements or channel identification, you want those to be played over your airwaves, you got to have an interface board to be able to plug in the repeater into the computer. Okay, so that's what this is about, is that interface board. Now I did design one, as you can see in your screen, but there's a couple reasons why I may not go down this path. And one of the big reasons is when you sell an electronic product, you're going to need tech support. Now, as we all know, not everybody's going to have a perfect situation where they get their product, they plug it in, and it works just fine. There's going to be times where someone's computer settings are all messed up, even though that has nothing to do with the circuit board per se, but it's still related that they can't get the board to work. And it might be their computer might be, have a faulty sound card, or whatever the case may be. You still have to order, or you still have to offer some type of tech support, and that can take a lot of time doing that. So that's one reason why I may not do this. The other reason is obviously the cost. I don't want this board to be expensive, or I'm just not going to do it. I want it to be as reasonable as possible. Now, I know people think, well, if you get if you order a lot of the parts, the more you order, the cheaper it is. Well, yes, that is true to a certain point, but I don't want 1,000 transistors here. You know what I mean? So I got to balance that kind of as best I can. Yeah, I won't get as many parts. I won't get 1,000 transistors. But if I get 100 of them, yeah, that's going to make, I won't get a break in the price per se per part. But again, I don't want 1,000 transistors here either. So that's another factor that I got to kind of consider, is what it's going to cost to build this thing. So, and also I want to point out a couple things here about circuit boards and about this circuit. Now, as you can see here, I will have it labeled. One end's the computer and one end goes to the repeater. So that will be labeled on the board. I also mentioned in my other videos that I'm going to have sound adjustments on here. Even though there's sound adjustments on the computer and on the software that you're probably going to be using, but it's best just to have another fine-tuned sound adjustment. So there's going to be a mic adjustment and a speaker out adjustment. Now, what you see, it's going to be the screwdriver type. Now, you're probably asking, well, why not just buy the type that has the knobs? Well, due to cost. That's why we're going to do it with the small screwdriver type of adjustment to try to keep the costs down. Now, the part that may actually be on the board may not look exactly like this, but it'll be a screwdriver adjustment type of part. Okay, so that is why I'm going with that. Now, the other thing too, that if you've been following my videos, we're going to need sound cables. And what I mean by that is, if you look on here, there's a microphone, and then you have ground for the microphone and ground for the speaker out. We got to hook this board up to the computer sound card, whether we plug it into the computer directly or whether we plug it into a USB sound card. Either way, we need sound coming off this board to plug it into the computer. Now, I know what you're thinking is why not just put a headphone jack on there so we can just plug in our cables and not have to solder the cables onto the board. And just to point out quick here, you see these gold pins. That's not going to be there in the final product. There'll be holes where you put the wire through and you would solder it on. I have the gold pins here just to kind of show you so you can kind of see it a little bit easier is why there's gold pins on here, but they won't be on there. But to answer your question, why I'm not going to have a jack on there is the reason being is when a circuit board is designed, it does not matter if it's a big company, it does not matter if it's Apple designing a circuit board for an iPhone, it does not matter if it's any other big companies or a person in their garage doing this. Every component should have a spec sheet. Okay, let's take for an example, let's talk about this transistor right here. If I look up the data sheet on that transistor, if you ever done that on an electronic part, you probably saw a page that had the specs of the part. How big it is, how far apart the leads are, how big a hole you need. All that information is needed when you design a circuit board because you need to know how far apart do I have to have the holes for that part to fit on the circuit board. Okay? So, with that being said, when you're dealing with a headphone jack, and if you want a circuit board mounted type of headphone jack, there are literally thousands of different types out there. So not only do I got to find one that's reasonable in price, I got to find one that I can get fairly easy, and I got to hope that manufacturer, after I find it, has a spec sheet, which they should, but I got to hope that spec sheet is correct. And I got to hope the information on there will work, because once I design the holes on the circuit board for that headphone jack, if something is off, now the headphone jack will not fit on my circuit board. Now I have a problem. To avoid all that mess and to save time on circuit board design, I'm going to solder the wires onto the circuit board. I'm just going to say it the way it is. That's what's going to be done. It just saves a lot of time in design, a lot of time trying to find a part. It just saves a lot of time. So that is why you won't see a headphone jack on the board. Now, also too, I'm going to, as I mentioned in my videos, this board's going to need power. We're going to need 5 volts. Now, that's not a big deal. You can get a wall wart, those little wall adapters. You can get one. You can buy one cheap. You may even have one laying around. It'll tell you on the wall wart if it's 5 volt DC for output. Now, if you have the good news is, if you have a wall wart, let's say you find one and it's 9 volt. No big deal. I'm designing this circuit board where it's going to be compatible with just about any wall wart that you have, because there's going to be a spot on the circuit board. Again, these metal terminals will not be here. It'll be holes. But there'll be a spot on the circuit board. There's a spot right here that will accept voltages from 6 volts up to 12 volts. The positive wire would go there. So if you have a 9 volt DC power supply, no problem. You can still use it on the circuit board. And that's because I'm going to install a voltage regulator. We're going to install a 5 volt voltage regulator. That's what this part is right here. Now, truth be told, this voltage regulator I have on here is probably a little overkill. This is a heavy duty regulator. This circuit board's not going to draw that much current. So I could probably go with a smaller size voltage regulator. And due to this circuit design, we're not going to need a heatsink on that voltage regulator, which is good news. That keeps the cost down. So, but at any rate, that's what that is. Now, if you do have a 5 volt DC power supply, then there is going to be a special spot where you can install that. And basically, what that does, it bypasses the voltage regulator. So there's a spot there that you would install if you're wall adapter is exactly 5 volts DC. You would solder the positive wire in that hole, and of course there is a spot for the ground wire, as you see here. No matter which one you use, you would put your ground wire there. Okay, so I want to point that out. Now you're probably asking, well, why not just put a jack there that we just plug in our power supply? Well, let me explain why we're not going to do that. And it's kind of the same reason why I'm not going to put a headphone jack. Because here's the thing, there's so many different size plugs that a person could have at their house. The wall wart jack at the end of that, or the wall wart plug I should say, there's sizes that are 5 millimeters, there's sizes that are 6 millimeters. To sit here and try to find a universal one, it's just not going to happen. And then on top of it, I got to find the jack, and I got to find one that's cheap. Then I got to find this. Hopefully the data specs on the hole spacings is correct, and then we got to design the circuit board with those holes. And to make a long story short, we're just going to solder the wires onto the circuit board. So that's why you're not going to see a jack to plug in your power supply. Okay. Also, too, I want to point out another thing that some people don't realize when it comes to circuit boards. And if you ever taken something apart and you look at a circuit board and you see spots on the circuit board where there's no parts, and you're probably thinking, well, did they forget a part? Why is there no part there? And there's a few reasons that may have happened. But one of the reasons is that during design testing, when you build a circuit and you test it on the bench, for an example, as you saw in my videos, I'm testing this circuit. Now, if I pick up some type of hum or a buzz, I add a capacitor to that circuit to filter out that hum. Now, when it comes to the final design, I may not need that. And the reason being I may not need that is because during the testing procedures, as you saw in my videos, I got long wires all over the place. Sometimes those long wires can pick up interference and noise. But to be on the safe side, you always design the circuit board for that particular part. Whether or not you use it will depend on the final product being tested. But if you do need to use it, at least there's a spot for it. You cannot add the spot afterwards. You can't drill holes to add the spot. Now, you probably have seen that happen, though, where a company takes a capacitor and they solder it on the underside of the circuit board across 2 leads. That's because during the final testing of the product, they find out they needed to filter some more filter, so they had to solder one in. You know, not a terrible thing, but that's what usually kind of happens when in those situations. So if I go down this path and you see the board and it's missing parts, do not worry. That part was not needed during the final build and the final testing of the product. Now, you also may have seen there might be times where you see a part. Let's take this capacitor again here. And you may see a jumper wire across there and not the part in place. And that's because that particular part, there still needs to be an electrical connection. So they have to solder in a jumper wire. There's times where you have to do that, and there's times that you don't need to do that, depending on the part that you're talking about. Okay, so that's where you may see during a final build a wire soldered across, or a spot where there's no part. That's the reason being. Now, also too, I'm going to add, as you can see here, there's going to be holes, just holes, okay, right here in the corners. And that is because I am not going to sell this in a case. And the reason being is, again, because of the cost and the size of the unit to ship it. So if you want to install this in a case, probably would be a good idea to install it in a metal case to help with any interference. There is holes in the circuit board where you can use standoffs so that the circuit board is not touching a metal case. You could use plastic too, but they kind of recommend usually metal just to kind of help with interference, and then to ground the metal case to one of the ground pins on the circuit board, probably the ground pin for the power supply. Would be not a bad idea. So at any rate, but that's why there's going to be holes there so that you can mount the circuit board if a person chooses to. Okay. Let's see what else. As for the DB9 connectors, as you can see here, I designed it so that it uses the PC mount type of connectors. I have not priced those yet, so hopefully they're not too terrible in price, but I would prefer to use that. A guy could just go with solder in the wires, like you would solder, let me get my pen here. You would solder wires onto these terminals, and then the wires would solder onto the chassis type of DB9 connector like I've used in my videos when I built the circuit. So a guy could do that too. But I'm going to hope to go with the PC mount DB9 connectors, unless if they're really expensive. We'll have to check. But at any rate, as you can see here, I do have a circuit board design. I'm still testing the circuit, but this is about how it's going to look. Like I say, it may not be exactly like this. I'm still tweaking this, but this gives you an idea on how this is going to work and an idea on how it's going to look too, more or less. So, at any rate, I hope this video is helpful in explaining this. If I do decide to sell these, I'll make a video. I'll post the information on the website and on my YouTube channel. If I decide to go down that path, I'm not sure yet. But at any rate, if you have any questions or comments, please post them down below. Please subscribe. Thank you and have a good day.